Greetings, the Astro 30 here again, and yes, this is part 4 of the plus minus 30 volt power supply build. Today I'm doing the hardware such as drilling the front panel and mounting some internal components. By this stage at part 4 I was expecting to have the project completed by now, but due to shipping problems from eBay from China, that's not going to happen now. I've been to JCar this morning and got some stuff that I need, and I'm in no way advocating for them in any way, but they are the most major electronic supplier in Australia. I've got some heat shrink tubing. I've got 3 different sizes, so we've got a bunch of M4 4mm nuts. Got the associated bolts for them, they're M4 10mm, and some 4mm washers, pack of 25. I've got these terminals. One of these is going to be for the earthing terminal. They're a 6mm hole, and they're a fairly decent width. They're about 18 gauge there on the thickness of the metal. So now that's probably overkill for an earthing lead, but it'll do the job. Now this contraption is what's known as a nibbling tool. You cut a hole in a piece of metal and then you use it like a pair of snippers, scissors, so you can actually cut out weird shaped holes in front panel work and any sheet metal really. This is designed for 18 gauge maximum, aluminium, unhardened steel, copper and plastic. This is what I'm going to be using to cut the square hole out for the VA meter in the front panel, and we'll see that a little bit later. And something I haven't had for a few many years is a decent center punch. These are one of these automatic ones where it goes click, click, click to put the dent in your metal work or even plastic work or whatever it is you're working with. I've got a terminal block. I only need 2 of these. This is just so I can mount the transformer primaries in one end and then wires out to the switch on the other end, because I don't really want to run both primaries to the switch, because you've got to switch both the active and neutral, because there's a little neon bulb inside the switch that makes it light, so both the active and neutral have to go to the switch. And rather than having 2 wires coming up to the switch on either side and then one coming out, just have one coming in, one coming out. So that's what the terminal block's for. An LM7812 positive voltage regulator. This will become apparent later with what this is for, but I'll leave you guessing for what that's for. I've got some heavy duty rated wire. This is going to be used for wiring the mains. Got brown, blue and green, a metre of each. And last but not least, some TO3P transistor isolators, pack of 4. This is a HP1174, and these are compoundless. In other words, you don't have to put any heatsink transfer compound on the device or whatever it's attached to. These are thermally conductive, and this is for both those transistors on those modules to mount to the rear of the panel on a heatsink. So that's why I've got the isolators. I was talking about that yesterday. So that just leaves me with this. And of course this piece of 18 gauge. This by the way is how thick 18 gauge is. It's about 1 millimetre. Now with the front panel, I was doing some thinking overnight whilst drinking and whatnot. I wish my voice would work. I was thinking of leaving the panel the size it is and then just sticking it in the middle. Saves me a task of modifying. It should still look alright. I do actually have the front panel printed. Just one sec. Now here it is here, and as we can see, that's going to look reasonably okay stuck in the center of the panel there. So that's the layout for it. Not a rather large hole to cut out for the VA meter, power switch, a load on-off switch. Meter range is for selecting what voltage measurement you're doing, whether across both modules or across single module. except it's going to have to be negative based. Anyway, we've got the outputs, positive, negative, 2 current limit LEDs which will illuminate when the current limit is hit. I seriously cannot speak today. The voltage and current pots. So that's basically what I'm going to do, is I'm going to print out another one of these on some self-adhesive label paper and then stick it on the panel. And for the back panel where I've got to put the IEC socket, well, I'm just going to measure that by hand and drill it and then cut it out with a nibbler. Now, this front panel, actually I don't think is aluminium, I think it's steel. I might have misspoke last night. But it's still only 18 gauge. As you can see, it's only no more than 1 millimeter thick there. So the nibbling tool should be able to cut through that. What I'm going to do is I'm going to make a quick modification to this layout. I'm going to put 4 6 millimeter holes, or patterns to be drilled like these. So I'm going to drill out 6 millimeter holes either corner, so I can get the reamer, nibbler tool, whatever you want to call it in, and then cut it up to one hole, turn around, cut it down to the next hole, turn it around, cut it back, etc. And then finally file out the hole straight. Now, because there's a overlaying lip on that meter, when you put it in, if this hole is a little bit messy or rough, it's not going to be noticed. So the first thing I'm going to do is load up this and modify the panel a little. I don't know if you guys have ever seen me use this program, probably not. It's called Front Panel Designer 2.0, ironically. And I've just placed 4 of these hole drill guides in here, and I'm going to move them into position in a minute. So I'll do that, put them roughly on the line. And I made this size 6 millimeter, which should be plenty of room for the nibbler. That's pretty huge. There we go. So I'll put that there. It's probably still a bit big, so I'll make it even smaller. And stick him up in the corner. Somewhere around about there. I think that looks pretty cool. So here it is here. That logo doesn't look too bad. I mean, the toner cartridge in this printer is kind of knackered. But it's a refilled one too, so it's not the best quality. I did have 2 new ones which I got sent, but they're actually the TN2350 instead of the 2N2250, so they're the next model printer up, which is totally useless to me because they won't fit. Anyhow, I'll deal with that later. So I'm going to print this now out on the proper material, and yeah, cut it out and stick to the front panel. Okay, so I've cut out all 3 sides bar 1, well, I should say all 4 sides bar 1. You'll also notice I've made these holes larger because I put the reaming tool up to the first one on the printout test and it wasn't big enough, so I changed it to 10mm. So I'm just going to peel off one edge of the label. Now I can actually now cut this bit off that I don't need, so that can go away now. And with sticking labels on things, I always peel off a bit at the back of the label like that, so I can place him on whatever it is I'm mounting it to and, well, line it up, get it straight and, you know, central to where I want it. In this particular application, it doesn't need to be perfectly straight, accurate, but as long as it looks reasonably straight. So I'm happy with that there, so I'm going to press down that corner or edge. Now I can slowly peel back the backing and smooth on my label. Just I'm doing it this way so I can make sure that I don't get any air bubbles or ripples in the thing, so it's actually going on there flat. Because otherwise I'd have to wet it and take it off, dry it, and then start again with a new one. And I don't really want to do the extra work if I don't have to. Right, so there we go. There's the front panel with a label on it. Does it look a little bit tatty? Yeah, but it does the job of telling me what each of the things does. Okay, well I've got my pilot holes drilled now. I just used a 2mm drill bit. A couple of those holes where the meter is went a little bit off, but that's really neither here nor there, because don't forget, the inside of all that is going to be cut out anyway. But the rest of the holes are drilled nice and where they should be. And so all I've got to do now is enlarge the holes to fit components such as potentiometers and like a 3mm hole for this little tag that sticks out on the potentiometer. So I'm going to do that now, and yeah, we'll see what happens after I come back. Okay, that was harder than necessary. The hardest hole to drill was the power switch hole. That's going to need a little bit of massaging to make the switch fit. Just a little bit of a file, but yeah, and a bit of the paper's lifted on this side. Not much I can do about that. Anyway, all the holes are drilled and to the correct sizes, so I can now lose a clip. Go about trying to ream this out. Ooh. I think I just broke the tool. Yeah, I did. I broke it. So I'm not going to be able to do it that way. Well, so I'm going to have to file it. That's going to take an awful long time. It's a shame about that. I just broke the tip off. So this is what you do to do it the hard way. I've just got a hacksaw blade, made the hole a bit bigger so I can fit the blade in there, and really? There we go. We have a hole. Now all I've got to do is file that out flat so the thing will fit and go buy a new hacksaw blade. So that's one way of getting a square hole, albeit the hard way. I knew it was going to be hard. Yeah, not quite yet. So the sides are a little bit. There, it fits. Okay. Thank God it fits. Now I'm going to make this hole a little bit larger for the switch with a file. There we go. Switch is in there. I'm happy. And a bit of super glue will fix that edge of the paper there. So just think, I've got to do that for the rear panel yet. Cut a square hole out for the IEC socket. That's going to take some time and be fun. Get the crap out of there. Just a little dab of super glue just to keep it on the panel. It's starting to not look too bad now. I can make sure that's stuck down. I've got super glue on the edge there. Have to wait for that to dry. Make sure that switches in, which it looks like it is. Okay. So before I can mount the pots though, I'm going to have to get a new saw blade because, well, as you saw, I busted it. Oops. Right, well, that hole could use a little bit more massaging to make that fit properly. There we go. The VA meter is now mounted. It only took a little bit of effort. Now it's a little bit loose, but I can probably fix that later by dropping a dab of glue behind it. Okay, so what I might do now is start putting on some hardware so it starts to look more like a power supply. Because, well, I've now finished drilling all the holes I need to in the front panel anyway. Well, I get the feeling that that's stripped. That's stripped. Okay. Alright, be a pain in my ass. So I'm going to have to go out and buy a new black banana socket, but that's no big great deal. Yeah, that's filthy now. Alright. Next. Put this back in its home. That was awfully tight. Okay, that's what she said. Yeah, that's a bit dirty now. Well, I suppose it's just going to do the job. Now, as for these pots, well, I suppose I can cut them without needing a new hacksaw blade. Ah, I just broke it even further. This is a shitty blade, this one. Okay, the easiest way to cut these off without a vise is to use the broken hacksaw blade, which broke again twice, and was to actually mount it in the panel and just use the panel as a way of holding it. So I don't have to go too wild with that. Just enough to take any sharp edges off the end of the shaft. So with that, I'm still going to have to go out and get another banana socket and a hacksaw blade. So I'm going to have to go back to JCar yet again. I'm not happy. And because, well, I can't use that. It's, yeah, starting to look quite good, isn't it? Well, I think it is anyway. Look at that. There we go, we got a voltage knob and a current knob. It doesn't appear very central. Like, I don't mean central to the panel, I mean central to the knob itself, the pot itself. Kind of off, but anyway. So, that hard work is paid off. Meters in, switches are in, need a new BNC, banana socket. Need to enlarge this hole to, these two holes to 4.5mm. That's not really a big great deal there. Need to go buy a new hacksaw blade because, well, I can't use this thing anymore because it's busted, and I won't be able to cut the aluminium sheet out to the right size and needs to lay at the bottom here without it. And the reason, this took an awful long time to cut those pot shafts off, but the only reason is because it wasn't tight. These blades have to be tight in the handle that they come with, and that's what gives you the cutting force, is A, the handle, and also the tightness of the blade. If the blade is loose, well, you're just going to break it, which is exactly what happened in this instance. It broke. Now, the next fun task is to cut a square hole out in the back panel for this IEC socket. And my battery's going flat, so I'm going to have to put the camera on charge a while, but that gives me an excuse to go out and buy some more stuff. And a short time later I'm back. I've got a new black binding post. It's only about $1.95. I've got 3 new hacksaw blades, the cheap ones, and a hot snot gun. Now, I was thinking whilst I was out that with cutting this square hole, what I should have done was drilled a 12mm hole in each corner, probably filed it a bit with that triangular file I had, taken the blade out of the hacksaw, slipped it in the hole, then put the handle back on, and then used the handle to cut the hole. It probably would have been A, quicker, B, easier, and C, a lot more effective. I also drilled out the 2 LED holes to 4.5mm, and I've slipped 2 red LEDs in there, and they're nice and tight, they're not going to go anywhere. So I'll just pop this in, and this time I'll try and not cross thread it. That went a lot better than the last one. So right now I'm just waiting for the hot snot gun to warm up, because I'm going to put a bit of hot snot around the back of this module to stop it from moving around. I mean, I didn't really want to be fricking about all afternoon, to be honest. This should have been done like several hours ago. I should have been up to cutting out the aluminium sheet, drilling 4 holes in the side corners of it to mount it to the inside of the case, and had been done with it by now. But no, it didn't work that way. Okay, so let's see if this hot snot gun is hot enough yet. Just going to put a little bit of hot snot on each corner, just to stop it from moving around. That's all I should need to do. And just for giggles here, I might put some around this switch on just 2 edges. Probably there would be better, just to make sure that that stays in position. That should be all I need to do with that. Okay, and yeah, a few seconds later that's nice and solid in there. So that's not going to go anywhere. I've left the back panel off because the next thing I'm going to do is Let's do the hard part. Mark and cut the hole for the IEC socket. Now, but first I'm going to need to know what sizes this is. I want to make sure that this is square, so I'm just going to do that. Okay, so that's me cut out. I want to work out where to put the holes for the heatsink, because I'm going to drill them as well, might as well, saves me drilling them later. So I'm going to come in about that far, so that's what? Well, that scale's going backwards. Put it up here. That's about 75mm should be good enough. This is the fun part about doing electronics, is having to make enclosures, or drill enclosures I should say. Alright, I'm going to get to drilling. I'll drill it out and come right back. Now if we look at it, how close these holes actually line up. So really, it's not going to take me very long with a file to cut that out. So I'm going to do that next, because that's the hardest part, and we'll come back. I want to do it now before I lose my lines. Well, that was a lot easier than them VA meter thing. Now, all I have to do now is just clean up the panel with some alcohol to get rid of the dirt and marks. Or I don't even need to use alcohol, I could probably just use Mr. Bean. Now that I've basically finished doing all the filing and stuff I need to do inside the case and whatnot, I'm just going to first wipe out the bottom, and it'll make it smell nice for a bit. And take these sides off. Mr. Bean won't hurt the desktop either, so that's pretty much clean as it's going to get. Just get the dirty fingerprints off the corner. Yeah, that's satisfactory enough for me. I'm quite pleased with that. Now I'll just mount the socket. So the AC is going to come in on the back of the left hand side, so I'm just going to put the socket in that way around and find some bolts and nuts. Alright, I think that's going to be tight enough, so let's check it out with the power cord. Yep, that's fine. Now, the next order of business is to cut this piece of aluminium. So, I've decided I'm going to make it 250 millimeters wide. Now, with these hacksaw blades, you want to put them in your saw with the blades facing towards, or the teeth facing towards the front of the saw, because when you look at the saw like this, you want the teeth to be going like that at an angle all the way along. So, because when you're driving it forward is where you want it to be cutting, not the other way around. All the teeth are facing forward, not backward, forward. So the easiest way for me to do this, do it there. I'm just going to run the blade up against the wood. We can bend it out the way as we go. Okay, it's cut. Now, it doesn't matter if it wasn't all that straight either, because I'm still going to file it with it still clamped to the desk. and a short time later it's almost flush. So I'm going to safely say that's pretty much done. It's about as flat as I'm going to get it. Doesn't have to be perfect, so I can unclamp it from my jig. Get rid of that. And apart from a little bit of war damage on that corner, it's pretty much perfect. So now I can marry it up to the case. It actually goes the whole entire length of the case, which is quite nice. So I'm going to leave it like that. So I've got that drilled. Now I need to take this apart, remove the bottom, and somehow I'm going to have to try and get that in there, because do I have to take it apart and do it? That's the question. It wants to play a little bit of silly buggers with me, so I'm going to massage the hole. That'll line up better. Okay, this screw is off as well, so what I might do is I'll tighten the 3 screws that I've got in it, and then I can drill the final hole. So I'll take this screw back out, and that one's off by 1/2 millimetre or so. Now it's not. You shouldn't really do that with drill bits, but that's what it looks like inside. There's still that sticky thing there. Yeah, I'll get it off later. Right now, that's going to be the chassis, so I can do all my drilling and mounting all the transformers and the PCBs to this. Ground it, yeah, go from there. Now I was going to wire it today, but honestly I can't be bothered now because of the amount of work and effort I've done into this. That's a project for another day, but so far I've done the hard part, which is doing all the hardware, except of course drilling the holes in the heatsink to mate up with the holes on the inside here so the transistors can mount to it. But again, that's for another day. And just a final note before I go, that's what it's going to look like when it's together. Now I had to take it apart because I tried putting the bottom panel onto this square thing with the base plates mounted to, and because my holes were drilled slightly off, it was pulling the thing out of square, so it was jamming, trying to get it into the bottom half of the case, and I could not get the front on this side to go down, and it was scratching the hell out the inside of this. So what I did was took it all apart, I re-drilled out all those holes to 4mm, just so it gives it a little bit of, wiggle room. And now, once I tighten the 4 bolts back down, the thing does go together quite nicely. I'm very pleased. Now I can't get the top off. For some reason now the top's stuck. Well, why? There we go. Okay, so it is a little bit of a bastard, but yeah. And I can get it apart for working on it. I need to like that, and then just to put it back together I just sort of have to maneuver it around, but because I was the one that built it, I know how it works. So that was nowhere near right. See, I've been struggling with this for the last half an hour and having difficulties. Helps with the front panel straight. There we go. Let's fix that. Yeah, so I've been struggling with it for the last half an hour and trying to figure out what was wrong with it, and just massaged the holes in the plate that I've installed. Solved the problem. There we go. That's what it's going to look like when it's finished. It's kind of neat, isn't it? Anyway, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. And as usual, this is the Astro 30 saying see ya, have a great day, and I'll see you in part 5. Hopefully.